In the last video, I talked about confidence intervals, which tell us a range of plausible values for a population parameter, such as the population mean, with a specified confidence level. What I'll talk about in the next few videos are hypothesis tests, and these, instead of looking at a range of plausible values for the population parameter, ask whether a very particular value is plausible or not. And so confidence intervals and hypothesis tests are related. They're just coming at the same question from a slightly different angle. So to put this in context, we're going to think about our home prices and ask the question, does a population mean of $255,000 seem plausible given our sample of 30 home prices? So there's different flavors of hypothesis test that we can think about. So the first flavor that we'll think about is called an upper tail test. And so an upper tail test in this context would be, can we reject the possibility that the population mean is 255 in favor of the population mean being larger or greater than 255? So it's an upper tail test, and there's a greater than symbol here. Similarly, a lower tail test would ask the question, can we reject the possibility that the population mean is 255 in favor of the population mean being less than 255? So lower tail test, and we've got a less than symbol. And then the third flavor is a two-tail test, and that would come from a question like, can we reject the possibility that the population mean is 255 in favor of the population mean not being equal to 255? So a two-tail test has a not equal sign. So we're going to focus on the upper tail test first, and then in a later video we'll talk about the other types of test. So an upper tail test, the first step for any hypothesis test is writing down the null hypothesis and the alternative hypothesis. And for us, for this example, the null hypothesis is that the population mean is 255, and then we're doing an upper tail test. So the alternative hypothesis says the population mean is greater than 255. So upper tail test, and we have a greater than symbol in the alternative hypothesis. If the null hypothesis is true, if the population mean really is 255, then the sampling distribution of this t statistic is a t distribution with n-1 degrees of freedom. And let's just do a quick sketch of that t-distribution. So remember, it's kind of like a bell curve. Okay, and it's centered at 0. And just to give you an idea of the scale, plus and minus 2 would be around here. Okay, and approximately 95% of the distribution is in between plus and minus 2 for this t-distribution, which is a t-distribution with n-1 is 29 degrees of freedom. Okay, so that's a rough picture, and it's often helpful to have a rough picture in mind when you're doing hypothesis tests. So the intuition behind a hypothesis test, and here we're using something called a rejection region method. In the next video I'll talk about a p-value method, but we'll do the rejection region method here. The idea is that if the t-statistic that we have from our sample, because in our sample we can calculate this thing, if it's not too far from 0, then we can't reject the null hypothesis. Conversely, If it's much larger than 0, then we do reject the null hypothesis, and we reject it in favor of the alternative hypothesis. So that's the logic here. If we get a value of the test statistic that isn't too far from 0, we do not reject the null hypothesis. Okay, and we end up saying, you know what, a population mean of 255 seems plausible. We're getting a test statistic that's believable, given that the null hypothesis is true. On the other hand, if our test statistic is way out in the upper tail, then we don't believe the null hypothesis is true. We reject it in favor of the alternative. So that begs the question, how far out in the tail would the t-statistic have to be before we reject the null in favor of the alternative? And so that decision is determined using something called the significance level of the test. And the significance level is something that the analyst determines ahead of time, and a typical value you'll see here is 5%. And that's going to determine a rejection region that's beyond a critical value, and if our test statistic is beyond that critical value inside the rejection region, we end up rejecting the null in favor of the alternative. If we have a significance level of 5%, then that critical value would be the 95th percentile of the t-distribution for an upper tail test. So let's see how that all works. So I'm going to do an upper tail test for population mean equal to 255 is the null, population mean bigger than 255 is the alternative. I'll calculate my test statistic. So here's the formula, and then I can just plug in all my numbers. So 278.603, that's the sample mean. 255 is the hypothesized population mean. SY is the sample standard deviation, and root n is square root of the sample size. So I can do those calculations inside R, or inside whatever statistical software that you're using. So here's my mean and my standard deviation, and here's my calculation of the t-statistic. Just plugging in all the numbers, and I end up with 2.40 to 2 decimal places. So I could draw that on my picture. So 2.40. I'm gonna draw it there. Okay, so it's kind of out in this right tail, but the question is it far enough out in the tail for me to reject my null hypothesis? Or is it close enough to 0 that we cannot reject the null hypothesis? So we need to do a little bit more work before we can make that determination. Next step is to set the significance level, which we're going to set at 5%, which is a very typical value. And then the critical value for an upper tail test, when we're using a significance level of 5%, will be the 95th percentile of a t-distribution with 29 degrees of freedom. And so we can consult a t-table to find that out, or we can use software. So the qt function in R tells us that the 95th percentile is 1.699 to 3 decimal places. Okay, so I could draw that on my picture too. Okay, so let's do the 1.699 there. Oops. Terrible writing, but you get the idea. That's 1.699. Okay, it's the 95th percentile, so if I was to shade this area here, that would be my significance level, 5%. Okay, and then we make a decision. The critical value, this 95th percentile, tells me where the rejection region is. It's an upper tail test, so it's any test statistic bigger than this percentile would be in the rejection region. And our test statistic is 2.4, so it is bigger than our critical value, so it's in the rejection region, so we reject the null in favor of the alternative. So in other words, our final conclusion, and you should always draw a final conclusion when you're doing a hypothesis test, bring it back to what you were testing in the first place. We've rejected the null in favor of the alternative. Our sample data suggests that the population mean is greater than $255,000 at a 5% significance level. So here's a neater picture of what's going on. We've got our critical value, 1.699. That's the 95th percentile, and so the significance level, 5%, is the tail area to the right of our critical value. And then our test statistic here happened to be bigger than our critical value. It's in the rejection region, and so we reject the null hypothesis in favor of the alternative. So I've got another quantity marked on my picture here called the p-value, and I'm going to talk about that in the next video.